Okay, so now we want to find the volume of the solid obtained by rotating the region bounded by y equals x cubed, y equals 8, and x equals 0 about the y-axis. Okay, so our region is bounded by y equals x cubed, y equals 8, and x equals 0, and we're rotating about the y-axis. Alright, so let's sketch our region. Y equals x cubed, that looks something like this. Y equals 8, that's a horizontal line. And x equals 0, that's a vertical line, and that's really just the y-axis. So that means this is our region right here, this shaded area. Right, so it's bounded by the y-axis, the line y equals 8, and then the curve x cubed. Okay, so we're going to rotate that about the y-axis, and we're going to get a solid. It's going to generate our solid. So let's draw that. Okay, so we have x cubed. And now we draw the mirror image on the other side of the y-axis because we're rotating about the y-axis. And we have circular cross sections. Right, so we want to, when we were using the disk method and we're making these solids by revolving regions about axes, we want to think of everything as like stacks of of disks, right? So this solid is like a stack of disks, kind of like a stack of infinitesimally thin disks will give us the exact volume, right? It's like a stack of pancakes. Okay, so again, this shape is kind of like a gumdrop, an upside down gumdrop shape. Okay, so we're going to use the disk method, and this is for a vertical axis of revolution. So we're going to have the formula v equals pi times the integral from a to b of r of y squared dy. Okay, now something to keep in mind is everything here is in terms of y. So maybe it would be better to write this here, y equals a and y equals b, just to remind us that these aren't x values, these are actually y values, right? So r of y, that's going to be the radius in terms of y. Dy, that's means we're taking the integral with respect to y. So we want everything in terms of y. All right, so let's see what a and b would be. So a and b are the y values that bound the region. Okay, so the lower bound is down here at y equals 0. And then the upper bound, that's y equals 8. Okay, so our y values range between 0 and 8. All right, now let's figure out what the radius would be. All right, now the radius at the top of the solid is that line right there. But the radius changes as we slide down. It gets smaller actually. So down here the radius is different. So that's why we write r of y. So the radius is a function of y. All right, and now let's see. How would we figure out? We can draw that a circular cross section. Oops. Okay, so how would we figure out what r of y is? Now, keep in mind this point here we could write that as x comma y. Right, but you could write any point as x, y, so we can do better than that. It's a point along the curve, right? And the curve is y equals x cubed, so we could write x comma x cubed, right? Because y is equal to x cubed. All right, but now we said we wanted everything in terms of y, so we want to change this again. And we can do that because we have a relation between y and x, and that's y is equal to x cubed. Okay, so that means we can solve for x, and that's by cube rooting both sides. So then x is equal to the cube root of y. And we don't need to worry about plus or minus here because we're taking the cubed root. Okay, so that means we could also write this point equivalently as cube root of y comma y. Okay, and that's good because that now everything's in terms of y, and that's what we were looking for. So now what's the length of this? So what's the length of that line? What's the radius? So the radius is actually going to be the cube root of y. All right, and we can make sense out of that because it's the length from here to here, and that length is x. Right, but we said we wanted x in terms of y, so that's why we write the cube root of y. Okay, so then we can substitute into our formula. So the volume is equal to pi times the integral. We said y ranges between 0 and 8. R of y we said is the cube root of y squared dy. Okay, so we can rewrite that integral as pi times the integral from 0 to 8 of y to the 2/3 power dy. Okay, so then that'll set us up for using the power rule for integration. Okay, so I'll leave it up to you to evaluate that integral and make sure you can check that you should get 96 pi over 5.